Why do some buildings use concrete blocks and others use ceramic bricks? Hey, engineering enthusiasts, have you ever stopped to think about why some walls are built with concrete blocks and others with traditional bricks? Those seemingly simple elements that make up the structures where we live and work. Behind this choice, there's a fascinating combination of material science, economics, technical performance, and even regional tradition. But first, what exactly are these materials and why does the choice matter? Basically, the concrete block or structural block is a pre-molded component made from a mixture of Portland cement, fine aggregates or sand and coarse aggregates, which can be crushed stone or compacted gravel that has already been cured. The ceramic brick, commonly known as the Baiano brick or hollow brick, is produced by molding and firing clay in kilns at high temperatures, generally between 900 and 1000 degrees Celsius. Both are used to build walls, but their physical properties, production methods, and ideal applications are quite different. This difference affects everything from the construction cost to the thermal and acoustic comfort of the environment. To understand how each type of brick or block is produced, I recommend watching our video about bricks. I'll leave a card for it at the end of this video, right here. And what are the practical differences that influence the choice? Here come the fundamental properties that every designer and builder evaluates. The concrete block generally offers greater compressive strength than the common ceramic brick. Structural blocks can reach characteristic strengths above 4 MPa and up to 8 MPa or more, according to NBR 6136. Solid or good quality ceramic bricks can get close, but common hollow ones often range from 1.5 MPa to 3 MPa, according to Associação Brasileira de Normas Técnicas, Norma Brasileira 15270. This makes the concrete block the mandatory choice for structural walls, that is, those that bear the load from the slab and roof in structural masonry. Bricks are typically used for partition and enclosure, but depending on the height of the structure, they can also serve as structural bricks. In some cases, you can tell that a building with structural masonry starts being built with concrete blocks. And on the upper floors, which have lower loads, they end up using structural ceramic bricks. Thermal and acoustic insulation is a traditional strong point of ceramic bricks. The fired clay and the air-filled holes create thermal mass and offer better thermal inertia, helping to keep indoor environments cooler in hot climates. They also tend to have better acoustic performance, especially at medium and high frequencies, due to their density and porous composition. Simple concrete blocks have higher thermal conductivity, which means they can transmit more heat or cold. However, there are blocks with specific aggregates, such as expanded polystyrene or core designs optimized to improve insulation. Ceramic bricks are more porous and can absorb significantly more water than quality concrete blocks. This high absorption can lead to problems such as efflorescence, which are white stains, and in very cold climates, the risk of damage from the freezing of absorbed water. Because of this, they require more care on the construction site with protection from rain, and even in the specification of the type of coating and finish. Concrete blocks are generally larger and heavier than individual ceramic bricks. A standard block of 14 by 19 by 39 centimeters weighs about 10 to 12 kilograms. A common ceramic brick measuring 9 by 19 by 29 centimeters weighs about 2.5 to 3.5 kilograms. However, since a concrete block replaces several bricks, the laying time can be shorter with blocks, although they require more physical effort per unit. The dimensional accuracy of concrete blocks tends to be superior, making alignment easier and reducing the consumption of laying mortar. Both are durable materials when well manufactured and applied. Concrete is chemically more stable and less susceptible to moisture variations after curing. Poorly fired bricks, on the other hand, can be more fragile and susceptible to the effects of time. In areas subject to constant humidity or salinity, dense and well-proportioned concrete blocks generally perform better. The unit cost of ceramic bricks is usually lower than that of concrete blocks. However, the final regional cost per square meter of wall needs to take into account productivity, mortar consumption, and any structural gains. Logistics also play a role, as concrete blocks are heavier for transportation and individual handling. But the total quantity for the same wall area may be lower. The local availability of raw materials and factories greatly influences the regional cost. So, where is each material most commonly used and why? Here, engineering and practice come together. For concrete blocks, their high compressive strength makes them the preferred material and often mandatory by code for walls that bear structural loads in multi-story buildings constructed with this system. Its low water absorption and high strength make it ideal for footings and underground retaining walls. Relation to moisture or salinity. The larger size and dimensional accuracy speed up wall construction and make planning and control easier on large-scale projects due to standardization. Now the ceramic brick is used to fill the gaps between reinforced concrete columns and beams where its function is mainly as sealing and partition. Its superior thermal inertia makes it a popular and effective choice in hot climates for houses and two-story homes, aiming to reduce air conditioning use. Solid bricks, or those with high aesthetic quality, are often used in exposed masonry, taking advantage of the natural texture and color. The ease of transport, individual handling, and cutting on site make it versatile for small projects and renovations. And in many regions, especially where there are good clay deposits, brick is the most accessible and culturally rooted material. But why isn't understanding the difference between concrete blocks and ceramic bricks so crucial? This is where your choice truly affects your wallet, durability, and daily life. Choosing between concrete blocks and ceramic bricks isn't just a matter of taste or initial cost. It's a technical decision that affects the safety of the structure, thermal and acoustic performance, the construction budget, and the completion timeline. Today, the industry is constantly seeking to improve both materials. We see concrete blocks with lightweight aggregates or improved geometries to achieve better thermal insulation. Ceramic bricks are evolving with more controlled firing processes and shapes that improve strength and make construction easier with interlocking blocks. In addition, the context of the construction site is paramount, including local availability and the skilled labor required for each system. The specific structural and architectural design, as well as the climatic conditions of the site, are decisive factors that go beyond the intrinsic properties of the materials. So, next time you walk by a construction site, take a look at the walls being built. Those gray blocks or reddish bricks represent much more than just bricks. They are the materialization of complex technical choices based on centuries of knowledge about materials and physics, seeking to balance strength, comfort, economy, and durability to create the spaces we live in. The history of civil construction will be written block by block, brick by brick. So, does the house you live in use concrete blocks or ceramic bricks? Have you thought about the difference between these types? Let me know in the comments. Right here on the side, there are two interesting video options that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave your like, subscribe to the channel, turn on the bell, and consider becoming a channel member. That's all, engineering lovers. Big hug. See you in the next video.